because we are going to move to the packet where this matches. So for example 7, we are going to be looking at a piecewise function, and this is the problem that is given to us. All right, please write that down. That is a piecewise function. I can never have a piecewise function without this inequality part given to me. If that inequality wasn't there, it wouldn't even be a function. It'd be all over the place, guys. I'd have x values with so many different y values. Okay, and then here's a few things to remember. Actually, a couple of things. Always start with the domain. Always analyze the beginning and end piece. I'm going to abbreviate begin, end, piece. Okay, so let's talk about what I mean. So what we're going to do, guys, is we're going to come up with inputs and outputs because we are going to graph this. So we need some ordered pairs. I'm going to get some ordered pairs, grab some ordered pairs from the first equation. So I'm just going to make a little t-chart here. Here's x squared plus 1. Then I'm going to grab some ordered pairs for that line below it. So x minus 1 is going to be over here. And again, we always start with the domain that matches the piece I'm looking at. I'm looking at this. What kind of shape does this make again? Yes, the parabola. Very good. And that has a transformation of what? What does this mean? Up 1. Very good. So we're going to look at this parabola based on this domain where x is less than 0. And we always start with a beginning piece. So my very first input is going to have a value of 0. So on my very first column over there on the left side, I'm going to type in, or not type in, I'm going to write a 0 right here. Let's write a 0. And remember, we want values that are less than 0, but I do put 0. So 0, 1, 2. Let's go ahead and get some output values from that. When I plug in 0 right here, 0 squared plus 1 is 1. 2 squared plus 1 is 5. And 2, just kidding, that's not 5. What is that? 2. Thank you. Is this one 5? Yes, thank you. I jumped ahead. All right, so I started with the domain, and then we always analyze the beginning and the end piece. This is the most important. Here's where it begins, and we'll talk about a moment where it ends. So if I graph this, guys, I did start at 0, but do I include 0? That's right. So when we graph this on our graph, this is an open circle. So that's where it begins, but where does it end? Look at the inequality again. We want x values that are less than 0 forever. So this graph is going to end with negative infinity. It's going to be an arrow over there on the left side of the graph, and it's going to represent negative infinity. All right, let's take a look at what's going on with this line. So on this line, I'm going to start with 0 because that's where the domain starts. So I'm going to plug in a 0 right here. I remember we want values greater than or equal to 0, so 0, 1, 2. Just keep them small. And then let's analyze our outputs. So of course, when I plug in 0, it's negative 1. And then the next output, and then the last output. All right, let's analyze how this begins and ends. So here's my beginning piece. Is this going to be an open circle or a closed circle when I graph it? Yes, let's write that. And then how does it end? We want the x values to be larger forever. So this is going to end with positive infinity with some sort of arrow on the right side of the graph. Okay, will you please turn to page 35? Because that's where the graph is that matches this. Okay, so here we go, guys. This matches this. Notice you wrote down what was given to us. Now we have some input values to actually make this shape. Let's go ahead and get started. Let's go ahead and graph this ordered pair 0, 1, but remember, draw an open circle, guys, because it's not part equal. So let's draw an open circle at 0, 1. And then go ahead and plot the rest of these ordered pairs 1, 2, and 2, 5. Wait, I have an error here, guys. What's wrong with this? Are these less than 0? Y'all, this should have been -1. This should have been a -2. The good news is it doesn't change the output, because when we square it, it's still a positive answer. Make sure you have negatives, because otherwise it would not fit in that domain. Put your negatives there. All right, now let's graph it. It is a -1, +2, a -2, +5. Okay, so you can kind of see the shape of that curve. Go ahead and draw your parabola, but y'all remember, it ends with a -infinity over here for the domain. All right, let's go ahead and graph the pieces for that line. I am double checking my domain because otherwise it would be a big mistake. Are my values greater than or equal to 0? They are. I'm good. Let's graph. So this time we're going to draw an ordered pair at 0, -1, but we're going to fill in this dot. That's going to get filled in right there. And then let's go ahead and graph the other pieces. And since this is a line, guys, use your ID to make a nice, clean, straight edge and extend this line all the way to the edge of your graph. And don't forget, it goes to positive infinity, so it gets its arrows. And this from left to right, checking for domain, I'm constantly touching the function. So this domain is what? What is this domain? It is good. It is negative to positive infinity, but not the range. Where does the range start? Yes, with a bracket. Yes, because it's filled in. And then when you scan up, again, you're going to be constantly touching a piece of that function to positive infinity. All right, let's go ahead and talk about f of 0. Guys, please remember, when it's inside parentheses, that's just the x-coordinate. That's all it is. I just want to know what matches this x-coordinate. So the answer we're going to put right here is going to be the y-coordinate. Now, where does x equal 0? Right on the y-axis. Yes. You drew 2 circles, but why is -1 the only answer? Yes, it has to be the one that's filled in. Good. Let's write -1. And one more piece of information. You have a discontinuity here. Is it a jump, a removable, or an infinite? It's a jump. Good. Let's write that. Good job.